Okay, you said what now? Okay, so what's my numerator here? How'd you get that? Okay, keep going. No. Those mistakes will gas you. You're taking the ACT, you know how to do about 50 of the problems, but you make $2,000 mistakes on half of them, your ACT score is an 18 instead of a 28. Those are the things that will kill you. Absolutely gash your ACT score. Stop right there, Talia. Okay. Octavius, what's next? You can simplify it further than that. Nope. So you're doing that, right? Are there any like terms there?
3x and 2x.
Okay. So what's 3x minus 2x? There you go. X, no.
What you mean?
Minus negative 2.
Plus.
Yep. Whew. So. So. I mean. Somebody made a million $2,000 mistakes.
What's your pick?
So in my mind, there's nothing to laugh about because that could be $3,000. I wouldn't. I mean just me. I'm not. I don't really laugh at a check with $3,000 on it. Now let me just be honest with you. Let me be honest with you. If this is too much, then you probably need to go ahead and either transfer or find a new Algebra 2 class. Because this is the tip of the iceberg. We're still in the first semester.
How do you get 2 up there minus 2? Huh? What? 2x minus 3x minus 2.
From the highlight part.
Now here's the killer part. Is that a hard problem? It's 3x minus 2x minus 2. Is that hard? No. None of this is new. None of it is hard. But if you rush, if you think you're smarter than you really are, if you don't pay attention to detail, it's about to start catching up with you. So what you need to do is you need to do this. You need to use this as an opportunity to really kind of refocus and re-hone your math skills. This isn't just, let me just see how fast I can do this. This takes precision. This takes a lot of care, a lot of attention to detail. It's going to take that next level if you really want to be successful. At this point, some people are going to decide, you know what, I'm just going to kind of go through, and they'll be the people who at the end of the year, they end up with about a D. They barely pass, they get by, they get their credit, and they're happy with that. And then there'll be some people who say, okay, I understand, coach, I just need to focus a little bit more. I'm gonna have to pay attention. I'm gonna have to actually do my homework. Walking around looking at today's homework, pitiful. Y'all are just writing stuff down. Just writing. So, It's kind of a moment of choice. But we'll see what happens. Number 2, the length of the side of a square is 2s minus 1 inches. What's the area of the square? It's usually helpful to draw a picture for problems like this. So if the sides are 2s minus 1, we all know what the area of a square is. One side times another side. So in the end, all this problem is, it's a little foil, little claw problem. 2s times 2s. 2s times negative 1. Once again, if you can't do that in your head quickly, plus 1, not minus 1. A negative times a negative is positive. Then, look, H and G are designed for the people who say negative and negative, positive. Look, it's there to trick you. They're going to do that. If you don't know the rules, signs are the same, add them and keep the sign, then you're going to pick the wrong answer. Correct answer is H. If you rush, you're going to pick the wrong answer. So you need a paradigm shift. A paradigm is a way of thinking. Your paradigm needs to change from, let me just be fast and get this done, to, let me make sure I get this right. Even if it takes an extra 15 seconds. Number 3, factor. What do they have in common? You always have to ask yourself that. What do they have in common? They have a 4, they have an x squared, and that's it. 12 divided by 4 is 3. Y minus 2 x to the what? Subtract exponents. 101st. This is a division problem. Divide everything by 4x squared. Division, you subtract exponents. That's what we've been working on for the past week. Past 2 weeks. If it's a division problem, you subtract exponents. Number 4. Is there a GCF? So am I done? No. We spent 2 whole days on this. This is a difference. This is a difference of squares. The square root of x squared is x. The square root of 16 is 4. The square root of y to the 8th is y to the 4th. Because y to the 4th times y to the 4th gives me y to the 8th. Do you remember what to do with the signs? 1 positive, 1 negative. So why am I doing factoring? Why am I doing a difference of squares? Why am I bringing up all these things? Why am I clawing? Because I guarantee you, it's going to show up in today's worksheet. So take a look in 10, 9, 8, 7, 6.
Teacher, please pardon this interruption, but this is a very, very important announcement. You received an email from Ms. Bellberg regarding the Insight survey. And we have a list of people who have not completed that survey. And it is very, very important that you go in today before you leave and complete that Insight survey. Go back down through your emails. That link was sent to you on November the 11th, November the 13th, November the 15th, and November the 18th. So it is very, very important that you go into your email today and you complete that survey before you leave. Thank you very much. Do not leave today without completing that survey. Thank you.
I already got it done. Now, yesterday we said the very first thing you do is check and see, can you reduce or factor? And we're doing number 20. And the answer is no, nothing to reduce right now. 3n and -2, they don't have anything in common, so there's nothing to factor there. Now, then we said yesterday, take one denominator and multiply it by the other denominator. Unless you can factor the denominator. Which one of these is factorable? The first one. This, by the way, this should be an x, by the way. I do not know why that says an n. So, rewrite the problem with this factor. You know, I gave you lots of room here, so make use of it. And how do you factor x squared plus x minus 6? Well, 2 x's. Factors of 6 that give you a positive 1. We know it's 3 and 2. Signs. Good. Okay. Now, at this point we would say the denominators have to be the same before you can add the numerators, right? Instead of one denominator times the other denominator, which would be a headache of a problem, wouldn't it? That would be a triple claw. Oh, I don't want to do all that. Let's just do this. I can make the denominators the same if I take this fraction and multiply it by x plus 3. So watch what I do. This one stays the same. Why? Because it already has all of that stuff in the denominator. That part stays the same. What do I have to add to the denominator to make them the same? This x plus 3. So come over here and put x plus 3. Now the denominators are the same. Now, there's two ways to think about this. The first way to think about this numerator is if I multiply the denominator by that, I have to multiply the numerator by that. That's my favorite way to think about it. Because this fraction has to stay the same. So if I do something to one part of the fraction, I have to do it to the other part of the fraction. The other way you can think about it is, what did I add to this denominator? X plus 3. So you can multiply 3 times x plus 3. Do you have to cross multiply here? No. Because this fraction already has the correct denominator. This side is already set up. It already has the complete correct denominator. So you don't have to cross multiply here. You only have to multiply this fraction times x plus 3. So the question that you ask yourself is, what is 3 times x plus 3? 3x plus 9. In this way, we have two fractions with the same denominator. And this fraction, we multiply the numerator and denominator by x plus 3. So let's slow it down. First we factored. Then we made the denominators the same. And if we change one part of the fraction, we have to change the other part of the fraction. Now that the denominators are the same, all that's left to do is combine like terms. So I'm working right here. Just to make sure that I don't make a mistake, I'm going to change that and change all of these signs. because whenever there's a minus sign, I see a lot of mistakes. So that minus sign, I change it to a positive and take the opposite of both of these. They were positive, so I made a negative. This was positive, so I made a negative. X can combine with negative 3x, right? What's that give me? Good, no $2,000 mistakes. Negative 1 combines with negative 9. Done. So, exact same thing as yesterday. Make sure the denominators are the same. If you do something to one part of the fraction, you have to do it to the other part of the fraction. Combine like terms in the numerator. I told you how to do that one. You're going to tell me how to do number 21. Up on the filing cabinet. There's no way you should have already lost that.
I didn't lose it, I never got it.
Why didn't you get it yesterday? Doesn't make any sense.
X squared minus 4n plus 3, right?
Good. Which is what? You say 3 and 1? I agree. Science. How can you get a positive 3 in the end with a negative in the middle? Both negative. Gotta be an expert. Got to be an expert. What's the first fraction denominator missing? Sure is. So let's multiply the numerator and denominator by n minus 3. Which is what?
Minus 12.
Okay, let me stop right here and ask you, are there any questions? Talia. Change what? Four n times n minus 3. How do you get negative 12n? 4n times negative 3. 4n times n, 4n times negative 3. So 4n squared, negative 12n. Because n minus 1 was already over here. N minus 1 is already in this denominator. The new thing to the party is n minus 3. So I multiply the denominator by n minus 3, put it down here, and I multiply the numerator by n minus 3. What are you confused about? Oh. Yesterday I chewed people, or last year I chewed people out constantly. People would come, knock on my door, interrupt my class. I would say, all you're doing is delivering a sheet of paper. You interrupt my class to give me a sheet of paper that I don't need right now. I would go crazy. Now they know. Just slide it underneath. Okay, what's last year?
Yeah, put the both n squared minus 12n plus 3 on.
Oh, look how easy this one is. Nothing to even combine.
Let's see.
Why you ain't talking multiply 3?
You know, thank you.
What?
Please raise your hand if you have a question. I love to answer questions, even with a knife in my eyeball. Or Tavius.
So when you go like this, don't factor after you already do.
You can't factor that. That's unfactorable.
Oh, well, if it's factored.
Don't. You would quadratic formula it to find out
Hello.
what the factors are. You don't want to do that. What it might ask you, the answer choice might have this FOILed out. This might be clawed. So it would be n squared minus 4n plus 3. You already have it. You've already got it right there. Okay, last questions. Make the denominators the same. If you do something to the numerator of the fraction, you have to do it to the denominator. Add the numerators or subtract the numerators if it's a subtraction problem. Don't forget to change the sign and do the opposite of the second fraction. Rewrite your final fraction. Pretty simple, pretty straightforward. You have front and back of this sheet. The back of this sheet is review from yesterday and a few of the same kind of problems that you just did. Let's get started.